Hi, welcome to this STAIR Tailored. My name is Sarah Powell, and I'm at the University of Texas at Austin. And today we're going to be talking about practice to research and then back to practice. And we're going to be thinking about concrete learning. So this is Adam Smith, and in a minute we're going to see a video where Adam talks about concrete learning. And Adam is a district administrator with a focus in mathematics, and he's going to talk about why it's so important to bring in concrete learning, especially for students with learning disabilities.
Much in math can for struggling learners can be just a bunch of numbers and symbols that really have little meaning. As the saying is like math is another language. So what the concrete does is it helps the student access it if they have trouble with just a jumble of numbers and symbols. It helps them make sense of it. So there's a sense making piece. The sense making in terms of just what do numbers mean, just at the basic level. What does 3 mean? It means an arrangement of 3 objects. What does 5 mean, etc. And then what does 5 plus 3 mean? Well, it means joining 2 groups, 2 sets together, or having a set of 5 and counting on from 5 to get to 8. So it's a sense-making mechanism that allows students access into the content without the barrier of just a bunch of numbers and symbols.
So that was some of Adam's examples from practice, and he was talking about this sense-making mechanism. And I really like this term, and that's where the concrete learning can help students make sense of the mathematics. And Adam gave us some really good examples of, well, 3 means 3 objects, and that's concrete, or 5 means 5 objects, and that's concrete. And I'll show you a few other examples in just a minute. So we leave our practice and we move to the research. And the research tells us that when we bring in multiple representations for students, and by multiple representations, I mean the concrete and the pictorial and the abstract, it leads to increases in math outcomes, especially for students with learning difficulties. And here are a few examples from the research. So for example, Margaret Flores and her colleagues, they did a really cool study where they used different types of concrete manipulatives and pictorial drawings to help students with their multi-digit multiplication. So they worked with students in the late elementary grades, and when they helped the students with their multiplication, they used different types of base 10 blocks just like this. They also used some drawings, so the pictorial, where they would represent hundreds with a nice square like this. They represented tens in this way, and then they used little ones to help students understand what does it mean to multiply 5 ones times 5 or 4 tens times 5 and so on. And so after they did this project with the students that they worked with showed improvement in their multi-digit multiplication. Now a little bit with the later grades, Trisha Strickland and Paula Massini, they worked with 8th and 9th graders, and here they used algebra tiles to help students understand, well, what does it mean to multiply, for example, x plus 2 multiplied by x minus 1. And with the algebra tiles, they would set them up in an array to help students really understand what the multiplication means within algebra. And all of the students that worked with them with these concrete materials, they made sense of the mathematics and they showed improvement in their math outcomes as well. And so as we leave the research and we go back to the practice, we want to make sure that as we are teaching students with learning difficulties, we're always bringing in concrete and pictorial examples. I'll kind of move over here so you can see the word pictorial examples, because as Adam said, many times students get confused by the abstract. They just think that the abstract is numbers and symbols. But when we bring in concrete learning, and I would also argue when we bring in pictorial representations, that's going to help students with that sense-making mechanism and help them understand the math in a deeper way, and it should lead to improved math outcomes. Thank you so much for tuning into this STAIR Tailored. We'll see you next time.